The next book I want to cover is this one, Michel Audin, Geometry. Very good geometry book. It's a book that covers fine geometry, Euclidean geometry, in plane, in space, projective geometry, conics and quadrics, curves, envelopes, and evolutes, surfaces in 3D dimensional space. So I really like this book. It's very nice. It's very beautifully written, and it's very modern too. It's not synthetic geometry like Euclid does. It covers the material of Euclid, but in a very modern form, using linear algebra, using vector spaces, but all still very nice and down to earth. So this covers some pretty cool stuff. Pappus's theorem we see here, we see a barycenter, a lot of very nice stuff. Using a suitable amount of generality, you see it covers groups, groups that are path connected, or n group. Very modern point of view of classical geometry. I really like this book, and I would really recommend to everybody because it's so very well written. But yeah, it's of course classical geometry. I'm not sure if you're interested in that. Next we have William Burke, Applied Differential Geometry. It starts with tensors in linear spaces, manifolds, transformations, the calculus of differential forms, application of the exterior calculus, classical electrodynamics, dynamics of particles and fields, calculus on fiber bundles, and gravitation. So this is a book of differential geometry geared towards physics and geared very much towards intuition. So this really tries to make the intuition applications of this stuff clear, and I think it really does it very well. I think it's a kind of differential geometry book that a physicist would be very much interested in. Provided of, I mean, it's not the most rigorous book. You won't really see too much rigorous topics in here, but it still is, pretty neat for intuition and for applications, because I think it really does show the intuition behind this stuff very well. So highly recommended to basically everybody. Sad part is that it doesn't really have much exercises, or maybe any exercises, so that's kind of a letdown. Next we have here The Classical Electromagnetic Field by Leonard Aegis, a book on electrodynamics. So the book covers topics like the electric field, electrostatic fields, the summation problem for charges, boundary value problems with conductors, general boundary value problems, dielectrics, the magnetostatic field, the summation problem for stationary currents, magnetic materials and boundary value problems, force and energy in static fields, time-varying fields, electrodynamics and relativity, the summation problem for time harmonic currents, point currents, perfect conductors and time harmonic fields, time harmonic fields in matter, propagation in imperfect conductors, and dielectrics. So a pretty classical book on electrodynamics. I don't know what more to say. It's pretty good. It lacks exercises, so that's not good. But it does. It actually has problems. Sorry. Yeah, but still 16 problems for an entire chapter. I don't know. So it's I would. I like this book, but I mean there are probably better books on the topic. Next we have this book by James Callahan, The Geometry of Spacetime, Introduction to Special and General Relativity. So So we see here relativity before 1905, special relativity kinematics, special relativity kinetics, arbitrary frames, surfaces and curvature, intrinsic geometry, and general relativity, and then finally consequences. Basically a book on general relativity and the geometry and the math behind it, and how it came to be, the history, and basically special relativity done mathematically, I guess, or with an eye towards the mathematics. Yeah, extremely good book. Really like this one. It's yeah, it's some amazingly cool topics. I think that you may be hard pressed to find somewhere else. But yeah, I do like this book a lot. Very nice. Next we have here this book by Falconer, Fractal Geometry, Mathematical Foundations and Applications on Fractals. So here's the table of contents. We start with the mathematical background, box counting dimension, Hausdorff and pecking measures and dimensions. Then we have techniques for calculating dimensions, local structures of fractals, projection of fractals, products of fractals, intersection of fractals, then applications, iterated function systems, self-similar and self-affine sets, examples from number theory, graphs for functions, examples from pure mathematics, dynamical systems, iteration in complex functions, Julia sets and the Mandelbrot sets, random fractals, Brownian motion and Brownian surfaces, and multifractal measures, and physical applications. So yeah, a pretty in-depth book on fractals, of course with some very neat graphics, but yeah, it's pretty neat. For instance, I'm not sure if fractals is a hot topic anymore. I assume it's not very much, but yeah, I do like this book. It's pretty cool book. Very nice. Then we have here Introductory Statistical Mechanics by Bauli and Sanchez. A book on statistical mechanics, so it covers the first law of thermodynamics, entropy and the second law, probability and statistics, the ideas of statistical mechanics, the canonical ensemble, identical particles, Maxwell distributions of molecular speeds, Planck's distribution, system with variable number of particles, Fermi and Bose particles, phase transitions, continuous phase transitions, Ginzburg-Landau theory, and then some appendices. So yeah, a pretty generic book on statistical mechanics. Yeah, pretty well done. Can't really comment much on it because I haven't really read much of it. But yeah, it's pretty nice. See, it likes exercises. Oh no, yeah, it has exercises. But yeah. Pretty cool. Next we come to one of my favorite books on number theory. A very good book on number theory. And that's going to be Kendig, A Gateway to Number Theory, applying the power of algebraic curves. So it does a marriage for the ages, viewing the whole algebraic curve, entering the world of elliptic curves. Every elliptic curve is a group, $1 million challenge. Every real elliptic curve lives in a donut, the genus, and in conclusion. So this is a very good book, introduction to one of the Millennium Problems, based on elliptic curves. It's a pretty short book, Quinthan. I highly suggest this book for bedtime reading. Don't even bother doing the exercises, there barely are any, but it's immensely good. It's immensely beautiful. I got so much joy out of this book. Just reading it and seeing the things that people came up with, it's immensely satisfying. Yeah, I just really loved it. Really loved it very much. I would basically recommend this book to everybody. Basically everywhere. You know, even if you're not interested in number theory, this book is such a beautiful written book. Here you see one of his ways of visualizing the projective, visualizing an elliptic curve, and visualizing the points at infinity. It's pretty neat. I haven't seen anybody else do it like this. I wish people would do it like this, because it's just very beautiful. So yeah, highly recommend this book to you, Crimson. Please read it as bedtime reading, because I think you're going to get a lot of joy out of it. I'm going to stop here for today. Mirror, next time I promise you a video filled with Fourier analysis.